Hey everybody, welcome back to Dr. Mandis's Chemistry Madness. Hey, we're going to talk today about the electrons. Not exactly what an electron is, but where they are. More exactly, where they might be. I don't know, it's the indeterminacy principle, you know? You really can't know exactly where the electron is and how it's moving, but we have an idea of where they are. And that's good enough, because people don't know exactly where you are, but they have an idea where you are, and that's good enough. You know what I mean? So let's go back to our atomic models, which is where I left off in my last video. On the left, we got the whole idea of the notion of the empty space of Rutherford, the little nucleus, electron cloud nucleus. Then we move over to the right with the Bohr model with concentric rings. Well, what we're going to do is we're going to zoom in on all this, and we're going to slice up these energy levels. And basically, we're just looking at each little level. You know what I'm saying? And we're going to zoom in on that and say, what can we slice that space up into finer little detail? Okay. One of the things we're going to use for that is the periodic table. Somehow this is going to be that. This is an atomic model. And I'll show you how to do that, because the cool thing about the periodic table as an atomic model is you get a periodic table handed to you on every test. You always have a periodic table. One thing that might help make this make more sense is think of a building, an office building, except not a regular building, you know, nothing like that. That would make way too much sense. Think of a building that looks like this, okay? It gets fatter as you go up, just like energy levels. Okay, you get further away from the nucleus, the bigger the ring, right? The ring further out is bigger than the one closer in. So what we're going to say is we're going to take our office building and break it into levels, man. You know, usually you're either on this level or you move up a level or move up a level, just like electrons. And you already know buildings, you know, they have floors, levels, and each floor is broken up into what we call, you know, rooms. You know what I mean? And every time in our office building, when you move up a level, you get one more room. Cool? And then here's a gig, and I don't even know if I'm counting right. Here's a gig. Inside a room is furniture, and people can sit on furniture, right? Well, what we're going to say is you got levels. Levels have rooms. Rooms have little furniture in which the people sit. Well, okay. So we're going to break our energy levels are into, let's first get it into sort of a diagram of energy, which is what we're talking about down here. Okay, we went from concentric little rings to something a little bit more useful. This little guy over here is our orbital diagram. I know I don't know what an orbital is. I call it an energy level diagram because it looks like a bunch of energy levels in a diagram. Anyway, pay attention. We got a little red electron here, which I now made green. That was stupid of me. Okay. And we have another green electron right there. And those little electrons that you see there in energy levels 1 and 2 are in energy levels 1 and 2. Ain't that groovy? We're going to draw electrons like little arrows. More about that later. Okay? But everything you could do on the little concentric rings, we draw dots like in middle school. We're going to put them as arrows into our energy level diagram. All right? Then our energy level diagram is going to get broken down into sublevels. Alrighty? Again, look at the periodic table. If you look at the periodic table, each of these rows is an energy level. Ain't that groovy? And then I'm not going to do all of them. Each row is an energy level, and each element is going to be an electron. If you notice, I took this little guy, moved him out of here, and moved him over here to finish off my row a little bit better. Okay? So if you look in the first row of the periodic table, it's called a period, but I'm calling it a row. In the first period, I'm numbered them 1 through 7 so I can talk. In that first one, all right, we have two elements, and get in the period in the atom, that first energy level can hold 2 electrons. How many do you think are going to be in the second energy level? Well, let's take a peek. In the second energy level, we got 2 plus 6 more for 8 elements, and yes, there are 8 electrons in the second row, in the second energy level. So every element is going to stand for an electron, and each row is an energy level. That's kind of cool. Alrighty. If you look at those rows, can you see how they break up into parts? Okay. If they break up into parts, man, okay, let me get rid of those things. Alrighty, let me get rid of the rows. Get rid of the rows. Get rid of the rows. I'm paying for. No, you're not paying for it. So be quiet. You're gonna break them up into segments. If you look, you got a little piece here, another one over there. In the third row, we got a piece here, a piece over there. You know, each those are our rooms. Okay, this guy we moved over to here. I erased it by accident. Okay, and so those are our rooms. Those are going to be our sublevels. So let's take a better look at the one diagram that I had there. So we took our things, our rings, 1, 2, 3, and 4, cut them up, and made them energy levels 1, 2, 3, and 4. Now what I'm saying is if you can zoom in on the energy levels, the first energy level gets 1 sublevel, the second one gets 2, the third one gets, can you follow the pattern? First one, 1, second one, 2, the third one breaks into 3 sublevels. I put them in red in here. I called them S, P, and D. All right. The fourth one also gets 4 sublevels. Every time it's just like the office building. Every time we add a level, we add a room. And our rooms are sublevels. Every energy level is broken into sublevels. Every time you move out an energy level, you add a new sublevel. Alrighty. Where was that on the periodic table? Well, actually, the third one is actually right here. This is where it kind of fails a little bit. Okay. This is the third row sublevel. That's a third row sublevel. This is a third row. Switch to purple for the fourth row. This is 4. This is 4. This is 4. And where's the new fourth one come in? Right here at the bottom. And we're probably never ever going to get there. Okay. But every one is 4. A better picture of that is in this one where I get the sublevels broken out. I moved my HE. That HE over here is tucked in over there. But basically, I got rid of the elements and just zoomed out a little bit so you can sort of see how it's all broken up. Okay. The sublevels are S, P, and D. They used to stand for something, but that was, oh my God, over half a century ago, 3/4 of a century ago, a long time ago. The letters stay, nothing else. Okay. So if you're in the first row, you're in the 1s, second row, 2s, third row, 3s, and so forth. If you're on the other side, like let's just stay in that second row, 2s, 2p makes up the second row. Cool. That's why I wrote N above it. For the third row, this is 3s, this is 3p. But this down here is the 3d, but it's in the fourth row. So what I always ask my students to write, on the periodic table, write n minus 1d. So if you're in the fourth row, you tell yourself, hey, I got 4 minus 1, 3d. All right, this is where that Bohr model, those concentric rings, breaks down. That third energy level, one little part of the sublevel is higher in energy than the fourth one. They actually kind of flex and all this sort of weird stuff. But just say, hey, I got the 4s lower in energy than the 3d. Not a big deal. Okay? We are then going to take all our sublevels, break them into orbitals. So over here, these are sublevels that we're not going to use, but these are orbitals. If the sublevels were the rooms that we had on each floor, the orbitals are kind of like a little love seat, a little tiny sofa. 2 people. That's the furniture that's in each room. Okay? And each little blank here, each blank that I drew, that represents the orbital. They actually have shape. They're a little bit of part of the space of the electron cloud. So yeah, they have shape. We'll get into that in a sec. But if you notice, every sublevel is broken down into orbitals. The 1s is only 1 orbital, which is why it's 1 blank. The p's all have 3. The d's have 5. Okay? And if we go back to the periodic table gig, you can see that. And I'm going to go to the ugly one first. All right? Oh, that's way too ugly. That's better. All right, if you look at this, in the S, we have 2 elements, 2 electrons. An orbital holds up to 2 electrons, like our little sofa held 2 people. In the P's, way over here, we have 6 elements, 6 electrons, 3 orbitals. So the P's would be 1, 2, 3 orbitals. If you look at the D's, if you count, you got 10 electrons there. 10 divided by 2 is 5. So the D's would be 5 little blanks for 5 orbitals. All right. But, whoops, got ahead of myself. What is an orbital, man? Orbital is just a region of space within inside the electron cloud that holds two orbitals. Remember, you get talking about a sphere. So we're just taking out one little bit of the sphere, okay? But it's 3D, it's got shape. The easiest ones to draw are the S and the P. And here's a dumb analogy, but it works, okay? And the fine print here, I got a bird's eye view of a house, square house, pointy roof, and a big giant dog, I guess, in the yard. The fence is the edge of the electron cloud there. The house is standing for the nucleus. The dog is the electrons. Is the electrons are the is an electron. So the electron can be anywhere in the yard. The dog will run around and run around the yard. Not a big deal to sort of picture, okay? And that's what an orbital is. An s orbital is a sphere around the nucleus that can hold up to 2 electrons, okay? The p orbitals are not spheres, they're little dumbbells, okay? They're like a little bow tie, okay? I always tell kids, picture one of those little long balloons, hot dog balloons, twist it and make a little node in the middle, okay? And that's the nucleus, because the yard is where the electron or the dog can be, and the dog can't be in the house because they're mean people. The dog's never in the house, okay? So the dog here is either in the front yard or magically in the backyard. It's called tunneling. It can go right through the house. So electrons can be either in this space or that space. And what you have here is, remember our p's I said are going to be 3. 1, 2, 3 of them. All right. So you have 3 of these little p orbitals arranged around each axis. You know, x-axis, y-axis, z-axis. And so you have 3 p orbitals. So what we end up with is this awful looking diagram on the right. All right. It's easier to picture the 2 energy levels. 1, 2. All right. And we could put our lovely little, 2 electrons in the 1. 2, 4, 6, 8 electrons in the 2, and the second energy level. Where are they over here? Well, you still would have 2 electrons in the 1s, 2 electrons, whoops, 2 electrons in the 2s, somewhere out here, Then you have a 2p, another 2p, and then another 2p along each axis of space. Sometimes as a chemist, we need to deal with the shapes of those orbitals and stuff, but seriously, first year high school chemistry, first year college chemistry, not so much. You really want to kind of use the energy level diagrams, all right, the orbital diagrams, and we're going to place our electrons on there, realizing that sometimes this gives us a better visual of the electron cloud. This is kind of ugly, especially if we go to 3 or 4 energy levels and get a real big mess. So we stick here, we'll fill in the energy level diagrams. I'll teach you how to fill in the energy level diagrams in our next video. All right, so hang in there, hang tight, take care. I'll talk to you later.